What is Hooke's law? Hooke's law we also know as simple harmonic motions. An ideal spring has equilibrium length. When the ends are pushed inwards, the spring inside is compressed. The bigger the force, the more spring is compressed. If the force gradually reduces, the spring expands until it regains its original shape. The spring is showing it has elastic properties. The extension returns to zero. When the weight and the upward or returning force are equal, the spring is said to be in equilibrium. A force defined as F equal to Kx, the proportions constant K is called the spring constant. It is the measure of the spring stiffness. To prove Hooke's law, we know that the force applied which is spring is relative to the amount of stretch, and the proportion is at constant value. Objective. First, to prove the spring force is proportional with the change in extensions of spring. Second, to find the spring constant. Third, to calculate the total energy absorbing in the spring.
The procedure of the experiment is, first we need to go to PhET Simulation and open the Hooke's law simulator. Okay, here we can apply a force, either stretch the spring, also we can compress the spring as well. For the experiment, we need to set up the spring constant to 200 Newton per meter. It's already 200 here, and the applied force is 0 Newton. By the way, before that, we need to click on the displacement and also the values here, because we need to see the change in length, or the delta x, the extension of the spring. Okay, then by using the same spring constant 200 Newton per meter, we need to collect all the data of the extension with different applied force. The force that we're going to use are start with 0 Newton, then 10 Newton, 20 Newton, 30 Newton and 40 Newton. Okay, let's start with 0. As we can see here, the extension is also 0.000 meter. For 10 Newton, we got 0.050 meter. 20 Newton is 0.100 meter. 30 Newton 0.150 meter, and 40 Newton is 0.200 meter. After we have done obtain and tabulate all of this data, we need to sketch a graph consists of force versus extension of the spring, delta x, as we can see in the result.
As the result after conduct the experiment by using the PhET simulator, this is the data that we obtain. For the 0 Newton of force, the extension of the spring we are getting is 0. For 10 Newton force, the extension of the spring is 0.05. For 20 Newton force, the extension of the spring is 0.10. Next one, 30 Newton force, the extension of spring we get is 0.15, and the last one, for 40 Newton force, the extension of the spring we get is 0.20. With the data that we have been obtained, we plot a Hooke's law graph. The relation of the Hooke's law graph is force versus extension of the spring. We plot the data onto the graph paper and we get a straight line. The straight line equation is force equal to the constant, which is 200 times with extension of the spring. This equation gonna be explained on discussion.
Okay, so here we can see the data and plotted graph obtained from this experiment in this manner so that we can discuss it clearly. So based on the force F versus extension of spring delta X graph obtained, we can see clearly that it is a linear graph, which means that force is directly proportional to the extension of spring delta X. As we can see here, when the applied force increases from 0 up to 40 Newton, the extension of spring increased linearly. Alright, we look back to Hooke's law, which states that F equals to negative K times with delta X, which F represents the force, K represents the spring constant, and delta X represents the extension of spring. So from the graph obtained in this experiment, we can actually know the spring constant by calculating the gradient of this graph. So to calculate the gradient of this graph, we choose 2 points on the line itself. So we choose 0, 0 point and 0.2, 40 points. To calculate the gradient, we have to divide the difference in y coordinate divide by the difference in x coordinate. Therefore, we get the answer 200 Newton per meter as the spring constant used in this experiment. Other than spring constant, from this experiment and the data obtained, we can also determine something by calculating the area under the graph. But first, let's calculate area under the graph. So to calculate area under the graph, as we can see here, it is a triangle. Therefore, 1/2 times with 0.2 and times with 40, and we get 4 Newton meter or 4 joule. So this is energy stored in the spring, otherwise called strain potential energy or elastic potential energy, as what we had learned in chapter 5. To get a better pattern in trend of data, we should repeat the experiment by increasing the applied force few times more. So this will help to maintain the integrity of the data. The importance of knowledge on how to interpret data based on the graph help us to achieve the objectives of the experiment. As what we learned in graphical analysis, when we have a graph, we can obtain other information through the axis, gradient, and area under the graph, which actually represents any related data. As we are using PhET interactive simulations to replace real equipment in the lab, the accuracy of data obtained is higher as observational error could be reduced due to usage of high technology measurement equipment in the simulation. As a conclusion, the outcomes of this experiment is as similar to the purpose of the experiment, which Hooke's law is obeyed. The applied force is directly proportional to its extension of the spring. The value of spring constant and energy stored in the spring can be obtained too by this experiment.